Hello, everyone. In the previous lecture, we have learned several properties of powers where the exponent is an integer. For example, we have learned what does that a to the power 3 means. It's defined as a to the power 3 is a times a times a. And we learned properties that for those powers, several properties of that, namely a to the power m times a to the power n equals a to the power m plus n, and a to the power m divided by a to the power n equals a to the power m minus n. These are powers with the same base. Now, if you have different base, a to the power m times b to the power m, when the exponent is the same, you can combine that. It becomes a to the power ab to the power m. And we also have the powers of the power a to the power m raised to the power n. This equals a to the power m times n. We define this for positive integer m and n bigger than 0, and m is integer. And then we also learned for negative powers, it's just defined as a to the power negative n equals 1 over a to the power n, the reciprocal of a to the power n. In this lecture, we're going to learn what does it mean for numbers like a to the power 1/3, or a to the power 1/2, or a to the power 2/3, or a to the power negative 3/4. In other words, we want to learn powers with exponents being a fraction. So first, we're going to define those using basically the property of those properties. In other words, we want to say that if we assume those properties are true, for not only integers, but also fractions, we're going to see what it means for a to the power 1/3, a to the power 1/2. First, let's remove one of the negative exponent. This is very easy to do because if we assume that a to the negative anything, let's say a to the negative x is equal 1 over a to the x, then a to the negative 3/4 is just going to equal 1 over a to the negative 3/4, right? So it's still the reciprocal. So as long as we know what it means for a to the negative 3/4, we know what a to the negative 3/4 means, what the value for that is. So for now, we're going to just focus on positive exponents. So positive exponent being a fraction. That will be the focus of this lecture. We're going to understand what it means that a to the power 1/3 or 1/2. Actually, let's focus on a to the 1 over n. What it means a to the power 1 over n. For this, actually, we're going to borrow the idea of a to the m to the power n equals a to the power m times n. If this property is true for all fractions or for all numbers, but also fractions, decimals, all numbers, then a to the power 1n raised to the power n is going to equal a to the power 1n times n, because a to the power m times to the power n equals a to the power m times n, right? So the exponent just multiply together. This equals a to the power 1. This means that a to the power 1n is the number let's call it a b, such that b to the power n equals a. In other words, a to the power 1n is the nth root of a. So a to the power 1n is the number such that if I raise to the power n is equals a. That's called nth root of a. And in some sense, this does look like a to the 1 over n. You can just read as a 1nth root of a is this number. A different way of seeing this, what is a to the 1 over n means is, let's just focus on a to the 1 over n. And let b to the power n is equals a. So b is the number such that when I raise to the power n is equal to a. Then a to the power 1 over n is just equals b to the power n. I replace a by b to the power n, and raised to the power 1 over n. It's going to equal b to the power n times 1 over n is equal b to the power 1 is equals b. So you see, again, I see that a to the power 1 over n is the number b such that b to the power n is equals a. Let's look at a few examples to see this in action. Let's look at example 1. What is 8 to the power 1/3? Now we know that 8 to the power 1/3, 8 equals 2 to the power 3, and this is raised to the power 1/3. And this, by the power property of a to the power m, raised to the power n equals a m times n, is equal to 2 to the power 1 over 1, 3 times 1 over 3rd, equal to the power 1, and equals 2. So you see a to the power 1/3 is the number such that the number raised to the power 3 is equal a. And for the 8, the third root of 8 is equal to, and we get that. Let's look at second example. 81 to the power 1/4. This is equals, realize 81 is 3 to the power 4. So this equals 3 to the power 4 to the 1/4. And this equals 4 times 1 over 4 because it's raised to the power. So the powers exponents multiply together. This equals 3 to the power 1 and equals 3. Again, 81 to the power 1/4 is really the fourth root of 81 because, you know, in your mind, you know that this is exactly because of 3 to the power 4 equals 81. This is equivalent to 81 to the power 1/4 equals 3, right? Another way actually think about from the equation point of view, right? When you have equation 3 to the 4 to the 81, that we know that if, as long as we do the same action on both sides, the equation still holds. So if I do the action of each number raised to the power 1/4, this is going to still satisfy. Okay, this is equivalent to this. And this, because the left side is 3 to the power 4 times 1 over 4 is equal to 3. So we have the definition of 81 to the power 1/4 is equal to 3. Okay. So that gives us the basically the definition of what does it mean a or any number to the power 1 over n. Now let's look at fraction exponents with more general forms. So we mean that a to the power, let's say m over n. We already know that what does it mean that a to the power 1 over n, right? So what is this? This can be written as a to the power 1 over n to the power m, or equivalently, the same as a to the power m raised to the power 1 over n. So you can either do this way or you do this way. Depends on the situation. Maybe one is easier than the other. In most situations, it's actually does not matter which way you calculate it, it's more or less the same difficulty. So let's look at another example. What is x to the power 2n to the power 1 over n? This is equals x to the power 2n times 1 over n is going to equal x squared. And let's look at example 4. What is 4 to the power 3 over 2? This, if we do the this way, you get 4 to the power 1/2 to the power 3. And 4 to the power 1/2, we know this is the second root, the square root of 4, which is 2 inside, and the 2 to the power 3 equals 8. Okay, this is the way that we do the 1/2 first and then raise to the power 3. Or 4 to the power 3 over 2, we can do the 3 first and then 1 over 2 outside, right? Because it does not change. 3 over 2 equals 3 times 1 over 2. So inside 4 to the power 3 is 64, and to the power 1/2 equals the square root of 64 equals 8. You see, both ways we're getting the same. So to summarize, in this lecture, we have learned what does it mean that a to the power 1/2, a to the power 1/3, or a to the power 1 over n. Once this is defined, we know how to define a to the power m over n, because this number is just equals a to the power 1 over n times raised to the power of m. And then we also know that a to the negative m over n, you don't worry about this because this is just a reciprocal of 1 a to the power m over n. So as long as I know how to calculate this, I know how to calculate this. Now, all these properties of a to the power original m times a to the power n equals a to the power m plus n, or the division a to the power m divided by a to the power n equals a to the power m minus n, so on and so forth. We are really extending this one by removing the constraint that the exponent has to be integer. We're assuming that m and n can be any real number. So we're assuming the property is true for any real numbers. So here, now we can do stuff like this. Another example. What is x to the power 1/3 times x to the power 2/3 times x to the power 3/3? By the property 1 here, you can adding the exponent together. So this is x 1/3 plus 2/3 plus 3/3, and equals x to the power 6 over 3, which is x squared. So you see that not only we define the powers with fraction exponent, we also know that how we're going to multiply numbers of powers of fraction exponent, and by the same extension, we know how to divide, and we know how to raise the power. So we have the full picture, all the operations available to us regarding numbers with fractional exponents.